Hello everyone. In this concept talk, we will be looking at vector addition rules or vector addition laws. The question is, how do I add two vectors up? Okay, so the question is how to add two vectors up. Right, and there are typically two laws that help us. One is called the triangle law of addition, and the other is the parallelogram law of addition. Okay, so the triangle law of addition, and the second is the parallelogram law of addition. Right. The first thing though is when you add two vectors up, what do you get in return? You get another vector. Okay, so I just want to underline these things. The triangle law and then the parallelogram law. Before we go to the triangle or the parallelogram law, if I take vector A, so say we have vector A and vector B. Okay, then the addition of vector A and B, and subtraction is nothing but a special case of addition, so I just want to maybe make a note of that. Is a special case of addition. Right, so there is nothing special about subtraction. So vector A plus vector B is going to give us another vector. And typically let me call that vector as capital R. Okay, so I will say that vector A plus vector B is equal to a vector R, and in this situation the vectors A and B are called the components of the vector R. Okay, so these two guys here that you see, vector A and vector B, are the components of R, and the vector R itself is called as the resultant of the two components. Okay, so the vector R is called the resultant vector. Right, and so the two important words that you come across here are the components, which is vectors A and B, and then the resultant, which is vector R, or you can say A plus B is equal to C. Right, so this is the component and then this is the resultant. All right, so now the idea is, okay, I have two vectors, let's say vectors A and vector B. I draw them up. How do I add them pictorially? And here is typically how we do it. Okay, just want to underline these here as well. So this is components of vector R, and then R is called the resultant vector. All right, so let me go to the triangle law of vector addition. So that's the first one. Triangle law of addition. And here is a basic idea. Let's say I have a vector A. Okay, so given a vector A, which I'm going to draw this way. So this is vector A. Then let's say I'm given a vector B. Okay, this is vector B. How do I add them up? Here are the steps. You take any one of these vectors as it is, which means that you don't change its magnitude or you don't change its direction. You just translate it somewhere. Okay, so I'm going to take the vector A as it is. I'm going to take this vector A and I'm going to bring it here. Okay, so I'm just taking it as it is, and then I'm going to take the other vector and position it such that the tail of the other vector is touching the head of vector A. So I'm essentially taking this vector B and I'm translating it. without changing its magnitude and direction. Okay, so here is what I'm doing. I'm taking this vector, copying that, and I'm bringing it here. So I'm essentially translating it in such a way that the tail of vector B aligns with the head of vector A, and then I get the resultant vector, which I'm going to draw in this color here, by joining the tail of A to the head of B. Okay, so this is going to be my resultant vector R, which is nothing but the sum of vector A and vector B. Okay, so these are the steps, and I'm going to just list it very quickly. Okay, so take vector A as it is, or conversely you can just say, okay, I can take vector B as it is, or conversely vector B. Okay, then the next step is translate vector B such that the tail of B coincides with the head of A. Okay, that's the next step. And then the last step is the resultant vector is obtained. Resultant of A and B is obtained by joining the tail of A to the head of B. Very simple and very powerful law. Okay, so this is the first law. The second law is called the Parallelogram Law of addition. Okay, so let us go and look at that right now. Okay, so the Parallelogram Law of addition, which is the next one. What is the basic idea here? The basic idea is the same. I'm going to take two vectors A and B. I'm just going to copy the vectors from before. Okay, so I'm going to take these two creatures, A and B. Okay, and I'm going to bring them here. And my question is, okay, how do I add up A and B using the parallelogram law? So the first step is, what I do is I take the vector A. I take the vector A, and then I bring it here. Okay, and importantly, I take the vector B and I move it or translate it such that the tail of vector B is pinned to the tail of vector A. So look at this. So I pin them by their tails together. Nice thing, isn't it? Then what I do is this. I take a line from the head of A and I draw it parallel to the vector B. Okay, so I draw a line from the head of A parallel to the vector B. I do likewise. I take a line from the head of B and I draw it parallel to the vector A. These are parallel lines, right? This line here is parallel to the vector B in the same color as vector B. This line here is parallel to the vector A in the same color as vector A. How do I get the resultant? All I have to do is join the pinned point together to the point of intersection of these parallel lines. Okay, and this is going to be the resultant R, which is going to be A plus B. Okay, and I'm going to outline the steps now. Okay, so the first step is pin the vectors by their tails. Pin the two vectors by their tails, right? And that's what you have seen here. They're pinned together by their tails. Then from the head of A, draw a line parallel to B. Likewise, from the head of B, draw a line parallel to A. And then what do? You join the pinned point. This is the pinned point. Okay. To the point of intersection of these two parallel lines to get the resultant. Okay. The resultant is obtained by joining or by drawing a line from the pinned point to the point of intersection of the parallel lines. And the important thing is the direction of the resultant. The resultant is always going to start from the pinned point and end at the intersection point. Okay, so the pinned point is going to be the tail of the resultant. Okay, represents the tail of the resultant, which is capital R, and then the intersection point which represents the head of the resultant, R. All right, and these are rules that we will be typically using in solving many of our at least introductory problems, and something that we want to have very deeply ingrained in our mind when we start looking at problems. Right. Thank you very much.